Greetings. This is Tu Hao. This is my name, and I'm here to present our term project for the course Economic Policy Analysis. It's called Prism, and it is a multi-agent AI market research simulator. What does that mean? It means that when performing the market research, we would often need survey data collected from real human respondents. However, this survey taking is rather costly, and it might not be an available choice for a lot of smaller teams. So this is our idea. This is not our idea. It is our attempt to make the process easier and more accessible to smaller points. And this is a term project for our class in National Taiwan University, and I'm a first year master's student in the Department of Economics. And this is more of a group project between me and my group mate Yan Ming-Chih. Okay, here the motivation of our project. So I will start from, sorry, I need to, okay, here. So the traditional market research method is rather slow because you would require a lot of professional teams to design survey and to reach people to have the surveys answered and aggregated. And the whole process actually usually takes months and it would cost a lot. That's why like the smaller teams, like students or some smaller startup may not have access to this kind of market research method. So that's where a LLM can come of help. And this research paper here shows that LLM can be of help in terms of market research. So that you can ask the AI to simulate a person with certain, let's say I'm living in Taipei and I'm a student. What would be my reaction to a new product designed or proposed by the team? And what would be the willingness to pay? What would be the price I want to pay? This kind of question can be simulated. And the research paper here shows that a lot of principle of economics, like the demand, the higher the price, the lower the demand, a lot of principles are followed, yet a lot of challenges are also discovered. And what would be the work we want to do? So the gap we found was that this kind of tool is still rather difficult for a smaller team to use because you would have to have quite some knowledge about LLMs or at least with programming to call the API and to do a larger scale simulation in order um, to achieve the level of significance or like for your survey research. So that's why we build this app. We build our product or project Prism. So we try to make the process of using AI to simulate survey response easier. So by just inputting your questions, research questions, it would help you to see or simulate the perspectives of many other stakeholder. So here I will explain how the app actually works in order to simplify the process of using this kind of tool to simulate the survey responses. So you can start from imagine how you would or how a person would conduct a survey research. First, you would have to describe your questions. That's still on the user side. But the next step would be that what kind of survey questions are needed in order to figure out, to clarify your research problem, and what kind of people you would want to survey on. What would be the potential audience or the consumers for your product or project? And so the first agent would be in charge of these two tasks. It would first ask you to clarify your demand for your problem. And next, you would propose some of the demographics of the population you would try to simulate the survey response on. And next, the questionnaire, the actual questions that would be sent to the AI agent for simulation later will also be presented to you for confirmation or for review. So the first agent would be in charge of that. And the next step, after every survey question is confirmed and all the demographic divide is clarified, we would move to the simulation part where each agent where this in this part, like each AI agent, it's not an agent anymore, it's more of a API call. And within each call, the persona settings, like the demographic, I'm a student in Taipei, or like you are a person working somewhere in Tokyo or in the US, I don't know, depends on your scenario. And by inserting these personal settings, and we would provide the survey questions designed earlier to the AI and ask them for the responses. And it would be conducted at a rather large scale in order to reach some results that have like significance in statistics, but it's also adjustable to the user's need. And after all the simulation part, you would have a lot of raw responses stored usually in JSON format. Yeah, it's in JSON format in our project, and the agent 2 will read the JSON raw response and try to comprehend the responses and to provide a conclusion or a suggestion for your market research problem. So they provide some recommendations, and all these answers and suggestions will be compiled into a HTML report for easier usage later. I will show a demo, a very fast demo that's not the final product, but it would show you that how the app work in a shorter time. So you can see here we have a policy description or the research question you have here, and you can choose the scale of the market research or the simulation. And here we have the digital privacy as our policy description, and it will actually be used. It will still be used in later demonstration. And we'll run demo, and the survey design will be conducted, and like okay, the segments will be decided, and the simulation will be part. And this is a toy example, so yeah, it wouldn't be this fast. It would be like intimidating that to happen. But you can see that, okay, the agent would design different segments or for the demographic. So you have professionals, parents, worker, or students, each with their different persona settings, and also some weight is like applied, but that doesn't matter that much actually. And each of the summary statistics to their responses are also calculated and reported. And presumably the raw data or the raw responses from each segment is recorded here. So this is a toy example. And yeah, there will also be some recommendations from the result. So you don't have to write all the code for visualizations or interpretation by yourself. But still, it's still possible because all the JSON raw responses are available. And after this toy example, we move to the actual final product. The final product actually looks like. And yeah, first we would have to insert your API key. And I will do mine. You can see it is truncated, doesn't matter. And we'll test it. Okay, this one's valid because I just turned it on. It's actually would cost me some dollars for the survey design. And here I will copy my prompt or more of a description of the survey question here. Okay, the simulation is on manga consumption in Taiwan, and it's also related to the piracy perception, and it's more focused on university students. But also within the group of university students, there would be different type of consumers in terms of different willingness to pay or different moral perception. And after that, we would, clarify. So the agent one, it would now call the API key. I'm using the Gemini as provider. So it would take a little bit of time. I think I'll crop this part, but it's also, informative to show. Okay, so now some follow-up questions. You can also let the agent decide. So within the students, what type of readers will be the most interested in comparing? So which group will be the most interesting? I think for me, probably those who use parity sources, while also have some acquaintance of like official sources. Like what would be the proper strategy to urge them or to encourage them to purchase more official product other than from the parity sources? Yeah, they can some more to select. I just found out. Manga fans, casual readers, all pirated. Okay, let's do so. And what kind of measure? This is a single select. Okay, let's see like willingness to pay and other optional refinements. Yeah, I'll just let the agent decide on something. And that it generates some survey. It would cost me some more because it's the API key isn't free. Even on the pro subscription, it's not like it's priced by the usage. You will see the survey questions later. So we'll wait, maybe fast forward here. Yeah, it's designing. Last time it was annoying. Okay, I wouldn't run the simulation because it would be super costly for a student. Yeah, it cost me around like 200 NT. In US dollars around like 6 or 7. Oh God, but doesn't matter. Okay, different segments and different questions are designed and different form. The question format is also adjustable. Yeah. And after this, you would be able to run the simulation. But due to the API cost, I wouldn't be running the simulation during the recording. So I will use the 2 simulations I ran before as the example to show what kind of result can be produced by our product. Okay, we'll move on to that later. Here would be the result report from the first simulation out of the 2 simulation we did. And here is the conclusion of some like recommendations provided by the last agent that okay, tier pricing models may be helpful for those students or to prioritize some other strategies. Yeah, so the actual responses is here, the suggestions, and what are the materials used in order to do this kind of suggestion? It is here, the raw responses. So, and the responses are the answers to the questions here designed by the first agent and will be in Likert format. So from a scale from 1 to 5, that's what Likert means. And yeah, and some open questions and the willingness to pay, like how much in New Taiwan dollar or like other currency unit you want to pay for each result. And the app itself, our product, would visualize the responses for you. We have some like built-in visualization code here. And you'll see like, okay, family focus respondents are less, like they don't prioritize the digital consumption in their life. So we see probably some patterns that can be used for verification. And some open questions are also asked. We will see, let's say, open here. But it's actually truncated here because I made some mistakes in the max token limitation. So it ran out of token trying to answer to the open questions here. So they're all truncated here. So it's not really useful here to make any interpretation. But still, the number Okay, but this kind of approach of asking AI to answer in numbers has a lot of problems. And one of them is that AI is not it's insensitive to numbers. So when you ask AI to answer the numbers, the answers will be concentrated into three or four, like in the middle. So here, like in the literature, most of the human respondents, the normal standard deviation would be 0.8 to 1.2. And the response rate here for us is like a lot less. It's like 0.1 to 0.26. So it's a lot less verified. And that leads to problem for identifications because like usually when doing inference, we need a variation in the responses in order to tell the relation between, let's say, your income and the willingness to purchase or to pay for a product. Yeah, so that's a problem. Another problem is that when designing the questions, like a lot of like the choices are never chosen, never selected. And also it could be a problem on the question designs, but it all can also be problem that asking AI to choose from the options may not be a good approach. And our problem is here, the willingness pay. So AI were asked to provide a number of like how much you want to pay for a streaming service, and like 99% of values, even though we ask them to provide any values, like most of the values land on the multiples of NT $50. So it's a multiple of like common numbers, probably in the training data of LLMs. So it's not really a good approach to directly to ask for the willingness to pay. And otherwise, if we instead a better approach would be to create some bundles of products and to infer indirectly from the AI responses. But that's still kind of too advanced for us. But in the next simulation, we'll try the SSR method and SSR. So here, what does SSR here mean? So now for the super rare in gacha games, it's the semantic similarity ratings here. So semantic mean it's like what a text mean in languages. So let's say the question here, the like card form question here, how often do you use the parroted source content? And we have the frequency from never to very frequently. So it's a scale from 1 to 5. And each anchor, the product, the AI, or in this method, each anchor would have some text, some sample responses that say, okay, I never use a parroted content in my daily life, as opposed to very frequently, I say, so I use parroted content every day, every night, something. I'm proud of that. So each answers would have corresponding anchors. And when receiving the raw responses from the AI survey taker, let's say this one, these raw responses will be compared with the anchor text and using the cosine similarity. So cosine is like, the triangular cosine. Imagine that the raw responses can be projected into a vector, and we'll compare the vector with the cosine, with the anchor text. And the more similar the two texts is, the closer it will be, the higher probability of it will be assigned to one of the 5 anchors. So here, yeah, on receiving this text, we would probably say, okay, it's more likely that it is an answer that would be never, would be the number 1 here. So here you can see the probability of it being assigned to each numbers. Yeah, that's what SSR mean. Okay, now knowing what SSR mean, I will switch to the result of our second simulations. So here, this is the report provided by, it's the same questions, but conducted in Mandarin Chinese. Because after reading this report from Harvard Business Review, we found that it is important to choose which language when using AI, because LLMs are large language models are trained in different language corpuses. So the properties of English training data, as opposed to, let's say, Mandarin Chinese training data, would be really different. And because here we are trying to look at the Taiwanese audience, so it will be important to ask the questions in Taiwanese Mandarin. But it is still like the limitation I feel here is that it's still rather hard to compare between the recommendations because yeah, all the recommendations looks rather legit, and it would rely on one's expertise to tell whether a response is reliable or usable or not. Yeah, but in this second simulation, we improved the method for AI to answer the questions. But does this really improve the, let's say, the variation or standard deviation problem? Like our result is that not really, but probably because this SSR method is more costly in terms of API cost because each questions it used AI only used to uh, answer in simple numbers or like A or B or like option one, option two. So it's a lot cheaper in that way. But in SSR method, AI were asked to answer in like a longer text, and we would identify which the corresponding rating and anchoring. And you can see in this graph, I'm sorry it's in Mandarin Chinese, that this is the standard deviation of the first run. And like we have like different questions asked in each segment. You can see that because it's more costly for in the second simulations, I actually had to uh, cut the scale of the simulation. So in the second simulation, the standard deviation actually performed worse. The standard deviation is like lower in the second simulation. Oh, the text is okay. All right. And that's due to the budget constraint of being a student. I will show you the cost here. And actually, for the simulations, I tried to set a cap for 180 New Taiwan dollar. That's around 6 USD. But it's like experimental. And Google betrayed me by spending over the cap. Yeah, by a lot for students. But yeah, if you are like a survey, if you are working or something in the company, it wouldn't be too much a problem. But for me, like, okay, it could be a better meal for me. Yeah, but okay, that's about the question of the second simulation. Other than Google trying to charge me some extra, money for the API, we also have some good result, I think, that is only possible under AI settings. Let's think about the SDB, the social desirability bias, that when you know that your answer will be, let's say, presented to your friend, you're very likely to change your responses because it would fit the social morality better. So what would happen if we tell the AI that, okay, now you're under an anonymous settings that your answer wouldn't be known by other people? Would that change the responses from AI? And in the second simulations, we do see like stronger patterns. So we have four different segmentations. So some people are more active on social media, and this is our like okay, budget conscious, loyal official platform users. And most of the other like three out of the four segments, the significant this kind of gap between the social desirability bias is not significant. You can see, okay, overlap 0, but it is a lot more significant for under the settings that if one is very active on the social media. So it's the interesting part because in real life settings, it's rather hard to control for this kind of social desirability bias and something that can be operational for those do AI survey. And we also see some, budget paradox. What does it mean? Here we have some really price sensitive consumers, but yet, even though they are very like budget constrained, they are still trying to support for the creators. And it's rather odd because like, okay, I want to try, it's not odd, but it's just a paradox because in order to support for the artist, you have to spend money, but you are budget constrained. Yeah, so yeah, some interesting result can be simulated. And whether this is can be like verified is another problem, but under this approach, we can try different combinations of the demographic settings of the population, and more possibilities can be implemented here. Yeah, that's about some good results. And next part would be my group mate, Yan Ming-Chih. He would present one of the simulation conducted by him about like the central bank. It was recorded in Mandarin Chinese, but I think he would figure out how to deal with the English captions. So yeah.
今天为了确认Prism 的政策模拟效果是不是在实际上是不是可行的，然后我就找了一些比较靠近现代，然后且已经实施的经济政策，然后观看Prism 模拟出来的反应是不是跟实际情况是一样的，然后我们就选了2024年中央银行第7波选择性信用管制，然后这是一些政策背景跟政策实际时间，还有政策内容，然后我就将它丢进 Prism 里面做模拟，然后模拟出来的结果大致上是这样。OK， 大致上是这样。然后我就把模拟出来的结果丢给GPT， 请他做一个比较，然后比较他给我们的结果是这样，系统结果跟实际状况相比之下，比较保守的地方，大部分都是正确，方向正确，但是有一部分是比较激进或预测过头的部分。我猜可能是因为我用的是 Gemini 的模型，我 code 是 Gemini 的 API， 所以 Gemini 的模型比较容易产出一些过激的言论或是过激的结果。所以最近用 GPT 感觉是，如果用 GPT 的话 ，GPT 的 API 的话可能会是偏保守，就不会出现这种预测过头。所以我认为这个 Prism 的模拟实际情况跟你选择的AI 模型确实有很大的相关，所以应该要慎选你用的模型。这样 ，OK， 大概是这样想。就是 Prism 的实际效果大致上是方向性是可用的，但是实际的数值可能还要再进一步优化。这样，好，谢谢大家。
Okay, from here it would be the conclusion part. And the major contribution, I don't know, the contribution of our project would be to make the overall process of utilizing AI for survey simulation more accessible for smaller teams. So it's more user-friendly and it is cheaper. And also, like the overall workflow is easier to use and it can be applied and extended to lots of different fields. But of course, there are a lot of things that we haven't tested due to the budget constraint of a student. So it's not ideal to complain about the budget, but still, like there are a lot of work to be done. Like the limitation here, like we still haven't resolved the variance issue that all of the responses will be still very concentrated to certain points. And also, if we want to extract the willingness to pay, it is better to compare between different like product bundles and to extract and infer the willingness to pay rather than just asking like how much you want to pay to AI. That's not an ideal approach. And also, yeah, the cost and rate limits at scale is the biggest issue and the biggest frustration when I try to like make progress in this product. And future work would be like some easier one would be to allow for multiple providers. And here, because we didn't have enough time, we only use Gemini, but it is still developed within the framework of light LLMs, which allows for different providers, so it's easier to be extended. And calibration with real benchmark means that we can have more real-life survey data provided or built in to the product. That when designing a survey or when choosing which segment of populations, it is more grounded on truth or reliable sources. And also retrieval augmented generation grounding. It means that, okay, we can allow for each persona to cite the evidence within the database so that they are making decisions more with more background, or like it is easier to verify why they perform such a decision. And by improving all of that, it will be easier to perform like statistical inference or analysis. And yeah, and testing the product on more domains. So like just banking and like retail would be like too narrow. It would be better to test the product on more domains and more policies. Yeah, thank you for listening to here. And if you are interested, like all of the code I placed it with my friends onto GitHub, so you can see the source code. And if you want to run the app, you can just follow the instruction here. Yeah, finally. And here you can also see like in the real life demo for designing the questions, it costs like not much. The most of the cost come from the actual simulation. Yeah, so thank you for listening to here. And I hope I hope you enjoyed it. And yeah, finally finish this. I will do the editing later. Okay, thank you, Tir here. Bye. Bye bye.